All right, so got a question here. Hey sir, I don't understand any of the concepts of this unit on the multiples of pi on 4 and pi on 6. Not my favourite sort of question to get because it usually means we must have missed the lesson. Maybe we did miss the lesson when we started. Try and ask a few more specific questions, but if we don't understand any of it, we don't understand any of it. Let's have a go. This is review of year 10 as well, so we should be all over this. What is it that we do with all of these multiples of pi on 4 and pi on 6 in the unit circle? That's from our notes. Let's have a look and see if we can remember exactly what's going on. I'll make that a little bit bigger there. So, steps involved in solving these questions. 1. Find the reference angle. How far is the angle you've been given from the x-axis? 2. Determine if it's positive or negative. ASTC, all stations to central, all students take crack, whatever it is you need to remember it. The sillier the better. Don't obviously take crack. Finally, 3, find the exact value from your best friend's little buddies. You've got your best friend, you've got your best friend's little buddies. They're going to clear up all your problems. It's going to make these so easy. I'll do a bunch of them. You'll be kicking yourself when you think, why didn't I get this before? Here we go. Let's start with pi over 4. I want to go with this one. Use a unit circle diagram to find the sine of theta, cosine of theta, and tan on theta for, well, we'll start with a pi over 4. So I'm just going to draw my diagram up the top here. Well, disappeared for a second. There we go. There's my unit circle. Doesn't need to be beautiful. Let's find the value 0. Pi is 180, remember. 2 pi would get me all the way around. So this must be halfway to pi, pi over 2. This must be 1.5 lots of pi. So that's 3 pi over 2. And then, of course, you've got 2 pi. And you could keep going round and round and round. And you can go backwards, all of that. We know how that works. Pi over 4, what quadrant am I in? Let's draw the one I want. And in fact, let's be really clever. And oh, well, that wasn't so clever, was it? Let's try that again. Let's save that really badly drawn unit circle. I could have done a nice, beautiful one, but that's the one we're dealing with. Too bad. Let's just keep going from there. So here, I've got a red pen. Let's put in where pi over 4 is. Well, it's halfway to there. Excellent. What do I know about the value of sine, cosine, and tangent? Well, sine is this axis. Oh, it'll be positive. Cosine's the x-coordinate, the x-axis. Positive. Tangent, where it hits the tangent axis, also positive. So they're all going to be positive in quadrant 1, and we can also remember that from our all stations to central. Very good. Pi over 4, what are the exact values? Best friend's little buddy, that's all I'm going to need. 1, 1, root 2. Pi over 4, pi over 4. Okay, so the sine of pi over 4. Find one of the pi over 4 angles, opposite divided by hypotenuse, 1 over root 2. Remember, what is it that we use to get the ratio? SOHCAHTOA. Okay, so for part A, if we want the sine of pi over 4, it's positive, and it's 1 over root 2, and I'm going to rationalise it and just call it root 2 over 2. If you're really stuck on that, you can look up one of my other videos or just ask me. We should know that, though. Cosine of pi over 4. When I do cosine of pi over 4, I'm going to go adjacent divided by hypotenuse. I could have done this one. Adjacent over hypotenuse is 1 over root 2, or root 2 on 2. So I'm just going to write equals cosine of pi on 4. They're equal at that point. Makes sense. It's an isosceles right-angled triangle. What about the tan of pi over 4? Well, not surprisingly, when you've got an isosceles right-angled triangle, the amount it goes up is the same as the amount it goes across every time. So the gradient is going to be 1, or what's the other way we think of the tan other than the gradient? Opposite divided by adjacent. 1 divided by 1 equals 1. Part B here, 5 pi over 4. Well, if this is pi, 5 pi over 4 is going to be 1 and 1/4 pi. So there's 1 pi plus another quarter. So that's 4 pi over 4. This will be 5 pi over 4. The reference angle, how far am I from the axis? That was a bit ugly. How far am I from the axis? Well, I'm still pi over 4 units away, aren't I? That angle's the same as that when they're both pi over 4. So I still use this best friend little buddy. All I need to know now is the only thing that's positive is tan. So the sine of 5 pi over 4 is negative root 2 on 2. The cosine of 5 pi over 4, in that quadrant cosine's negative, and the cosine of pi on 4 is root 2 on 2, so it's negative root 2 on 2. And finally, tan is still positive in that quadrant, so the tan of 5 pi over 4, The reference angle's still pi over 4. It's pi over 4 away from the axis, so I go to my best friend's little buddy, opposite over adjacent, 1. So it's positive 1. 7/4 of pi. That's like 1 3/4. So there's a quarter of pi. There's 1 pi, 1 1/2, 1 3/4 will be around here. This is the angle. 7 pi over 4 gets me to there. My x-coordinate is the cosine. It's going to be positive. Oh, it really annoys me when that does that. The y-coordinate is the sine. You can see it's going to be negative because the y-coordinate is below the x-axis. Or you just look at this and say, oh, C for central. Cosine's the only one positive there. Tan, it's got a negative gradient. It would hit my tangent below the x-axis at a negative value. So tan is going to be negative. But the angles that you use to work it out is still the pi over 4 because that reference angle is still pi over 4. All those angles, pi over 4, still the same best friend's little buddy. So, well, given that cosine was the positive one, cosine of 7 pi over 4 is going to be positive root 2 over 2. The sine of 7 pi over 4, we're in the negative quadrant for sine, so it's negative root 2 over 2. And the tan of 7 pi over 4, it's also in the negative quadrant. It's going to be negative, but remember the tan of pi over 4 is 1 over 1, so negative 1. Snuck in a little one here, they just gave me pi. Well, pi is just over here on the axis, isn't it? What's the cosine of pi? It's the x-coordinate. Cosine, x-coordinate, negative 1. What's the sine of pi? It's the y-coordinate. Am I either above or below the x-axis? No, I'm on the x-axis. I'm going to trace back to read my y-coordinate. Sine of pi is 0. Tan of pi, you can either do as sine theta divided by cosine theta, 0 divided by negative 1 is 0, or you just trace it all the way back till it hits your tangent axis. Remember, there's my tangent axis going down there. It's hitting it at 0 as well. There you go. Negative 3 pi and 4. Just go back around the circle this way. That's negative 3/4. Oh, look. It'll be the same as for 5 pi over 4. That looks like a 2. Why does that look like a 2 and not a 4? There we go. That's better. First one. Too easy. Let's find something a bit more challenging. Well, we can see here. This is just going to be the same, except their angles of pi on 3 and pi on 6. We can go back to our... Well, where to go? There it is. Best friend's little buddy for pi on 6 and pi on 3 is there. It's going to be easy enough to do. It's the same as the last one. Let's move on. Let's try some of these out of 3. Let's just do a selection. I might just do the right-hand column, why not, of question 3. That should keep us off the streets for a little bit, but they all work exactly the same way, so there's nothing too complicated here. Come on, let me scroll down a bit. So this is 10C.3, question 3, just in case we forget. Better label that. Question 3, and let's have a look at these. 4 sine 60 cosine 60. 1, you could just do it on your calculator, and a lot of you have calculators that give you exact values, but that's weak. Let's do it properly. I need my best friend's little buddies. We've lost them further up the page there. Let's just draw them again. So this is pi over 3, which is of course 1/3 of 180, 60 degrees. If you wanted to do it in degrees, this is pi over 6 or 30 degrees. 1, 2, and root 3. Oh, we don't have any pi over 4. Oh, yeah, we've got a pi over 4 in there. Good. So we have to draw our other little buddy of our best friend here. 1, 1, root 2. And of course, that's pi over 4, 1/4 of pi, aka 45 degrees. We're going to need a unit circle here. Once I've got that, we are away. Okay, they're all the things we need to refer to. Let's have a crack at C. 4 times the sine of 60 times cosine of 30. Well, in this first quadrant, 60 and 30, everything is positive. Then sine, then tangent, then cosine, all stations to central. All right, sine of 30, sine of 60, I should learn to read. 60, 1/3 of 180, so 1/3 of pi. Sine, opposite, divided by hypotenuse. Opposite, root 3 divided by hypotenuse. So the sine of 60 is just root 3 over 2. Cosine of 30, here's 30 degrees. Also adjacent, root 3 over 2, because it's adjacent divided by hypotenuse. Root 3 over 2, multiply that together. 4 divided by 2 divided by 2 is 1. And look, root 3 by root 3 is 3. So the answer is just 3. It's that easy, these ones. Let's have a crack at F. Cos squared pi on 4 minus sine of 7 pi over 6. Alright, first thing we need to clear up, let's just make sure. Cosine squared, that means find the cosine of pi over 4 and then square it. If I put the squared at the end, it could be find the cosine of pi over 4 squared, so pi squared over 16. That's not what it's asking. It's asking us to find the cosine of pi over 4 and square it. What is the cosine of pi over 4? It's adjacent divided by hypotenuse. It's root 2 over 2, we know it as, but for this one, because I'm squaring it, I'm just going to keep it as 1 over root 2, because I know that square root's going to disappear. Sine of 7 pi over 6. So pi is here, 7 pi over 6, well that's 6 pi over 6 is pi, so it's pi plus 1/6. I'm going to be in this negative quadrant. My reference angle, the angle in there, is still pi over 6, isn't it? It's pi over 6 away from the axis. Pi plus another 6 would be 7 pi over 6. So sine of 7 pi over 6 is going to be negative. Sine's negative in that quadrant. I'm below the axis, so the y coordinate is a negative. And the sine of pi over 6, 1/6 of pi, opposite divided by hypotenuse is a half. So here I have 1 over root 2. When I square it, I get 1 over root 2 squared is 2, minus negative 1/2, so it's plus 1/2. Or just 1. Let's have a go at the next one. I cos squared 5 pi over 6 minus sine squared 5 pi over 6. Well, 5 pi over 6 is going to be in this quadrant, so the sine is going to be positive. Cosine is going to be negative, isn't it? Because the x-coordinate is the cosine. It's going to be negative there. That's okay. What's my reference angle? Well, again, if this is pi, and the angle all the way around there is 5 pi over 6, this must be 1/6 of pi. I'm only 1/6 away from getting to pi. So my reference angle is pi over 6. Cosine of pi over 6 is root 3 over 2. So this would be negative root 3 over 2 in that quadrant. Quadrant 2, cosine's negative, so it's negative. Cosine of pi over 6 is root 3 over 2, and then I square it, minus sine of 5 pi on 6 all squared. So sine is positive. You can see it's got a positive y coordinate, so that makes sense. The sine of pi on 6, that's my reference angle, is a half. So it's root 3 over 2 squared minus 1/2 squared. When I square a negative, it becomes positive, so that's good. Root 3 squared is 3, 2 squared is 4, so I've got 3/4 minus 1/2. When I square it, becomes 1/4. 3/4 minus 1/4, 1/2. Last one here, let's have a crack at L. 2 tan 150 minus, well, divided by 1 minus tan squared 150. Let's see what that's equal to. Well, tan of 150, so 150, it's actually that angle again, isn't it? It's 150 out of 180, it's 5/6. Well, that's 30 degrees away, so pi over 6, we can also remember that's a 30-degree angle if we're dealing in degrees. So I'm going to need to refer to my 30-degree angle over here. Tan in that quadrant is negative, so all these values are going to be negative. You can see if I continued it down, it would hit the tan axis at the negative point. So the tan of 150 is negative, whatever the tan of 30 is. Tan of 30 is 1 over root 3. Oh, that's ugly because it's got that ugly irrational denominator. We'll deal with it in a minute. 1 minus tan squared 150. So this is 1 minus negative 1 on root 3 squared. Well, we should be able to fix this up pretty quick. So I've got negative 2 divided by root 3. Or in the numerator, I just did 2 multiplied by that. That's easy enough. 1 on root 3 when I square it. So the negative, when I square that, will become positive. 1 over root 3 will become 1/3. So 1 minus 1/3 is 2/3. When I have a fraction divided by a fraction, running out of room here, so let's go up here. I'm going to have negative 2 over root 3 multiplied by the reciprocal 3 over 2. Oh, good, they're going to cancel. How many times does root 3 go into 3? Root 3 times, obviously. So the answer is just negative root 3. And we are done. All right. Hopefully that's enough to get you started. I'm happy to do some more, but have a go at them first. That should be enough to remind you how to do all these ones. It's just a matter of finding the values, filling them in. There's nothing here that's any different. Use a unit circle to find all angles between 0 and 360 with a sine of a half. How do you do that? Well, you just find the two values where it's positive. So if I drew my unit circle, oh, go on then, let's just have a quick go at that one. Where would all the values where sine equals a half? Well, this is my sine axis. So a half is there, so there'll be one there and one there. From the unit circle, you know the angle must be opposite over hypotenuse. To end up with a half must be pi over 6. So this angle would be pi over 6. This would be 5 pi over 6 because it's pi minus 1/6. 5/6 left over. Same thing, if it was cosine, where are the cosine values both equal to negative something? Doesn't even matter what it is. Well, there's the negative cosine value. There'll be one in quadrant 2 and one in quadrant 3. I hope you get the idea. Have a go at them. I'm happy to do some more, but this has gone on long enough. See how you go. All right. Cheers, guys. Bye.